In our last video, we talked about unit conversions and primarily one-step conversions. Now what we're going to do is we're going to look at multi-step problems that use conversions in a process called dimensional analysis. Well, what is dimensional analysis? It's using units to solve mathematical problems involving measurements. The dimension, right, is the units. The analysis is the mathematical application. So let's dive right in. We're going to start with a speed conversion. So we're going to take a speed in miles per hour. We're going to convert it to meters per second. So MPH is miles per hour or miles over hours. So we want to start with our game board, and then we need to figure out what we're going to do with this unit. Well, where does the game start? Just like with simple one-step conversions, the game always starts in the top left. But here's where you have to be really careful. Here's the new little wrinkle to this. Miles per hour is the same thing as miles over hours. So when you have a two-part unit of some measurement divided by another measurement, miles per hour, meters per second, kilograms per liter in a density, anytime you have that two-part unit, that second part of the unit that's in the bottom of the fraction goes to the bottom of the game board. We should never have anything in the bottom left of a conversion table except for the second part of a two-part unit where something is divided by something else. So now here's the deal. We want to go to meters per second. So we're going to have to convert our miles to meters and our hours to seconds. The order in which you do that is entirely up to you. You can start by converting the distance and then the time, or you can convert the time and then the distance. Let's start with distance over time. So you can grab your conversion table. You might pause the video while you're doing that. If you have your conversion table, you might want to look at the relationship between miles and meters. There are two possibilities. I'm going to pick one of them, but you may end up picking a different one. So find on your conversion table 1 mile on the far left side of your distance conversion and read over to the column containing meters. And what you should see is that 1 mile is equal to 1,609 meters. And so our meters are going to cancel, and now we're in meters per hour. I want to be in meters per second, though. So what's the next conversion we generally go through from hours to get to seconds? Well, 1 hour is equal to 60 minutes. And now our hours are going to cancel. Again, if we were to stop and do our calculation at this point, multiply across the top, divide across the bottom, we would end up with our answer in meters per minute. We want meters per second, so we're going to need at least one more step here. We're going to put that 1 minute is equal to 60 seconds. The minutes are going to cancel. And if you look at the only units that we are left with here, we're left with meters per second. You want to multiply across the top, divide across the bottom. Again, don't forget, we want to go 35.0. 1,609 divided by 60, divided by 60. Make sure you hit divided by before both of those numbers. You hit times in your calculator for anything that's on the top. You hit divided by before anything on the bottom. And you end up with this big old long number. Well, we need to think about sig-digs. How many significant digits here? This is a measurement. 0 after the number if there's a decimal point count, so we have 3 significant digits there. Meters and miles are not in the same measurement system, so 1,609 has 4 significant digits. However, there are exactly 60 minutes in an hour. That has an infinite number of significant digits, and there are exactly 60 seconds in a minute. That has an infinite number of significant digits. So we have 3, 4, infinity, and infinity. And what's the smallest of those? Well, you're going to round this to 1, 2, 3 significant digits. We make sure we round down. Also, any units that you don't cancel out, meters and seconds, are the meters for your final answer. And since that's what we were looking for, hopefully you've played the game in such a way that the units cancel out except for the units that you're looking for. And that's how you tackle a problem in dimensional analysis. Side note, this conversion from hours to seconds shows up a lot. It turns out if you take 60 times 60 across the bottom here, right, you get 3,600. So 1 hour is equal to 3,600 seconds. If you want to file that away in your memory, you can certainly use that. It's not going to change the outcome of the problem. You're still dividing by 60 twice. If you multiply those two and then divide by 3,600. Okay, let's look at another one. How many seconds are in a period of 2.0 years? You have to ask the question now whether or not you're taking a measurement. If we're measuring, for instance, the rate at which a glacier is flowing, and we're picking some kind of a time marker to measure that movement. I don't know, there could be a number of things that you would be measuring. This is 2.0 years, implies that there's some kind of a measurement going on here, and we're dealing with two significant digits. Set up the game board. First step, always, always, always. Start with your given. Where? Top left corner. Great, 2.0 years. Now, play the game. What does that mean? Cancel the units until you get what you're looking for. So, what's our first conversion? Well, 365 days in a year. Again, are we looking for an exact calendar year, a definition of a year? Or are we looking for the number of revolutions of the Earth in the amount of time it takes it to go around the sun? So you could look at this as a definition, or you could look at it as a measurement. It just depends. We don't know the exact measurement, so we'll just go with the definition here. Again, those are your game pieces. Years have to go on bottom, days have to go on top. And so now you're in days. We're trying to get to seconds. Okay? Our next step, right? 24 hours in one day. Again, by definition, right? It's not exactly 24 hours. This is why we have leap years. But we're doing our conversion the best we can here. And then days to seconds, we just learned that 3,600 seconds are in an hour. That's a little bit of a shortcut. If you want to, 60 minutes in an hour and then 60 seconds in a minute also works. Our years cancel, our days cancel, our hours cancel. And lo and behold, we wanted to have an answer in seconds, and there we are with an answer in seconds. Again, if you're considering this to be exactly 2 calendar years, then we could take all of the numbers in this answer. This one's a little trickier. If we're going to take this to be a measurement of 2 years, we got to round for 2 significant digits. When you've actually taken measurements in the lab, it's pretty obvious that you put something on a balance or used a ruler. When you're doing these practice problems out of a book, or in this case on a screen, when you should and shouldn't round for significant digits can sometimes be fuzzy. So we'll kind of continue on with that conversation. You could, in fact, if you would like, also put this in scientific notation to account for getting rid of all those zeros. And there are 1, 2, 3, 4, 5, 6 zeros. That's usually about the point, somewhere about 5 or 6 zeros, where I'm going to expect that you go ahead and put your answers in scientific notation. There's no sense in writing all those zeros out. Not necessarily going to count it wrong. I'm just saying that's my preference. Okay, so let's tackle one more. Family pool herds 10,000 gallons. Determine the volume of the pool in cubic meters. So maybe you would take a pause and you would see if you can sort out what's going on in this problem. Okay, so hopefully you started here with a game board and you're given a piece of information in the top left. 1 gallon is equal to 3,785.472 milliliters. That is going to be a useful thing for us, given a piece of information that we've already talked about in this class. You could also go with the 1 milliliter equals a very small fraction of a gallon. Either of those is fine. But we're going to want to put the gallons on bottom and the milliliters on top. Again, whichever one of these conversions you want to use is okay. I will say, and this is really important, right? We have 5 significant digits here. If I pick this conversion factor, I am now limiting myself to 3 significant digits because the conversion factor has 3 significant digits. This might, under these circumstances, be a better conversion factor to use because I lose fewer digits. Again, I don't care which one you use, as long as you properly round off your answer, because we're looking more at a process here that I want you guys to be able to work yourselves through. Okay, so what's our next step? Well, we're trying to get to a cubic length in volume. And what we learned last week is that 1 milliliter is equal to 1 cubic centimeter. By definition, a milliliter is the volume of water that fits in a cube that's 1 centimeter on each side. And what that allows us to do is it allows us to cancel the milliliters out and get us to cubic length. What's our next step? Well, if we're going to convert centimeters to meters, how many centimeters are in a meter? Hopefully you thought in your head about Dora the Explorer, and then maybe also that there's 100 centimeters in a meter. But you have to do that 3 times. So you have to divide by 100, divide by 100, divide by 100, because you're working with a cubic length. You can either write it like this, or you can write it as 3 separate steps. 1 meter over 100 centimeters, next step 1 meter over 100 centimeters, next step 1 meter over 100 centimeters. Milliliters cancel, centimeters cubed are going to cancel, and then multiply across the top, divide across the bottom. Again, 10,000 divided by 0.000265, divided by 100, divided by 100, divided by 100. Make sure you hit divided by 3 times. Or you could just say, divided by 100,000. Okay? So that's what you get for your answer. You need to round for significant digits. Again, we're stuck with 3 significant digits because of this conversion. If you'd pick this other conversion factor, you'd have more sig digs. It's one of the reasons why you need to show me your work, not just give me your answer. I'm not checking your answer against an answer key. I'm checking your process against the process for doing dimensional analysis. Okay, so there are 3 examples. We'll have some other examples either in later videos or when we talk about this in class.